Na plus, the charge, the oxidation state will be +1. You have to take, if plus charge we are mentioning, that is +1 for Cl, minus the oxidation number or oxidation state will be -1. And for aluminium, because it can donate its outermost shell containing 3 electrons to form the stable neon gas configuration, so aluminium will going to have +3 oxidation states. So the oxidation number of the oxygen in most compounds is -2, while in peroxides, that is in H2O2 or single nascent oxygen atom containing oxides, will going to have, that is known as the superoxides, where each oxygen atom is linked to one another directly. The oxidation is -1 and -1/2, that is half you can take. In oxygen difluoride, that is in OF2 and dioxygen difluoride, the oxygen is assigned an oxidation number as +2 and +1. Means oxygen, when having bonding with the atoms which are electropositive, for example with the hydrogen or with sulfur, in that case we are expecting oxygen will going to have negative oxidation state. But when we are taking oxygen with the another elements which are more electronegative than oxygen, then oxygen will going to have plus charges always. Clear? So in general, oxidation number of hydrogen is +1, but in case of metals hydrides, in case of metal hydrides, because metals are more electropositive than the hydrogen atom, so we have to consider hydrogen as a anion. It will going to be like hydride. IDE suffix we are using where, when we are taking negative charges. Clear? So name we are writing here is lithium hydride or sodium hydride. Means when we are taking hydrogen also with another atom which is more electropositive than it, at that time hydrogen behaves like an electronegative elements and results in the formation of ide type compounds, that is hydride. And the oxidation number is -2 in case of lithium hydride. In all its compounds, fluoride has an oxidation number equals to -1. And next, the algebraic sum of the oxidation number of all the atoms in a compound must be 0. Means if we are taking any compound, in that compound the charge present on each atom, when we are adding that charge, at that time the net resultant will be 0. Clear? So that is because only then we can consider that the number of electrons loosed by one element in a reaction, equal number of electrons are taken by the another element in the same compound. For example, in case of NaCl, you can write Na plus and Cl minus. When you are adding +1 and -1, answer will be 0. Clear? So in polyatomic ions, the algebraic sum of all the oxidation number of the atoms of the ions must be equal to the charge on the ion. Clear? For example, you are having polyatomic ion here, in which more than one atom are used in the formation of the ion, which is having more atomic centers in the formation of a molecule. For example, in carbonate, you are having 1 carbon and 3 oxygen atoms. You can see that the charge you have mentioned here, equal charge, you can calculate through this formula. For carbon, you are writing X, you have to calculate the charge. And for oxygen, each oxygen charge can how much charge we can take? -2 and multiply with 3 equals to -2, that we have written over the polyatomic ion. And then X minus 6 equals to -2. And then when you are taking it into the consideration, after solving, the value of the X will be 4. Clear? Now when you are putting the value of X equals to 4 here, you can see on left hand side that 4 minus 6 will going to give you -2. Clear? So the same charge you have calculated here, that you are writing on the polyatomic ion. Clear? The charge on solving the left hand side after putting the value of x is the same as you are taking at the polyatomic ion. This is the -2. And next is the stop notation. According to this, oxidation number is expressed by by putting a Roman numeral representing the oxidation higher number after the symbol ic and atom in the molecular formula. Example, in a simple language you can say, if you are having any atom in its higher oxidation state, then you have to use the suffix that is the ic. For example, in case of iron, as I am having FeCl3, you can if you are having it in +3 oxidation state, then you can use ferric chloride, and if FeCl2, then you can use ferrous chloride. Means if oxidation state is lower, then you have to use ferrous OUS, and if you are taking the metal element in the higher oxidation state, then you can use ic and in the suffix. Clear? For example, in case of the gold, you can write it aurous chloride when its configuration is formal charge is +1, and auric when its formal charge is more than 1. Clear? That is 2. And next examples, you have to calculate the oxidation number of the sulfur in the following compounds: H2SO3, that is the oxo acid of sulfur. X you have to consider for the sulfur. Hydrogen will going to have always +1 charge. So how you can calculate the oxidation number? Firstly, write the number of atoms. Hydrogen are 2 and charge on each hydrogen is 1. Multiply the number of atoms with the charge plus then 2x, because for sulfur you have to calculate the charge and number of sulfur atoms are 2, and plus for oxygen, each oxygen carrying minus charge, multiply it with 3. Now you are having 2 plus 2x minus 6. Now solve this, you will get 4 divided by 2 equals to 2. That charge on sulfur will be 2. Clear? So in this way you can calculate the oxidation numbers. Note, for oxygen you have to take the charge that is the -2. For hydrogen always 1 you have to take. For sulfur -2 you can take, or if you have to calculate, then you will always going to have other elements like oxygen and hydrogen for which you can take the charge, as you are knowing about these elements. Clear? So these are the some examples that you have to try by yourself. For example, for Na2S2O3, oxo acid of sodium and sulfur, again you can calculate for sodium also the charge you have to take, that is the +1. For halogens, all halogens you have to take the charge -1, that is chlorine, bromine and iodine. Clear? So in this way you can calculate the oxidation number. So once try the another examples from your book also based upon the topic oxidation number, and if you are having any problem, then you can clear your doubts. Thank you.